right. So our next task right now is to learn a little bit about vertical asymptotes and holes. Okay, so what are those? Okay, so I have three graphs in here just to illustrate what vertical asymptotes are. So basically, it's an imaginary vertical line wherein your graph approaches towards that line, but they will never really cross that line. So in the first graph right here, okay, so our graph, the function is represented by this curve line, curve graphs, okay, and as you can see, this graph right here from the right side, it goes towards that blue dotted line, and as it goes, okay, my hand is a little bit off. Okay. So as it goes towards that graph, it'll just approach that graph really, really close from the right side, but it will never really intersect that vertical line. At the same time, from the left side, okay, if I could find my pen, from the left side of your graph, it also approaches that blue dotted line, but it'll just go really, really close as it goes towards that value, but it will never really intersect that. So that's the representation of what a vertical asymptote is. In the first graph, you only have one such line, you only have one vertical asymptote. However, on graph number two, letter B, you can see there are two vertical asymptotes. You see this pink solid curves. That's the representation of your function. From the left side, as you can see, it goes towards that x equals -2, and as it goes to the right, it will get really, really close to this first vertical asymptote, but it will never really close that. At the same time, this middle graph also gets closer to that line, but it will never again cross that graph. Same thing this way and same thing that way. So in this case, you have two such lines. You have two vertical asymptotes. In fact, the number three, you have three vertical asymptotes. So this is getting really complicated looking. But then on the graph, at least on the graph side, we can tell which ones are your vertical asymptotes because those are the lines again that are imaginary vertical lines wherein your graph approaches towards that line, but it will never really intersect. Okay. Now, but what is a hole though? Okay. So a hole on the other side, on the other hand, are points on your graph. Oops. Okay, I don't know that that's gonna get erased. Okay, are points on your graph that are not part of the function, meaning it does not really have a value for x in there or y. Okay, so for example, this one right here on the first graph, the other two graphs do not have holes, but on the first one, you have this hole right here. At what value of x? Well, that value of x is just right there at -1. Now, of course, that is the point. So technically, you could also get the value of y corresponding to that. But and you can see that by going this way, and that would be, I don't know, it's just an estimate. It's less than -1, so maybe negative point 0.8, point 0.6, just an estimation, and because that is an actual point. Now, depending on the question of your teacher, really the idea of a hole is that you because it is a point, it has an x coordinate and also a y coordinate. Okay, all right. Now, right now, at this point, we are actually learning how to recognize a vertical asymptote in a hole and holes given a graph. But what about if we are given equation? So let's try that. Okay, so all right, so let me give you some equations here. For example, okay, so let's try the first one. First, we will do vertical asymptotes and holes. Okay, so in an let me give a generic equation first. Okay, all right. Let's say I have an f of x equals x plus 2 x minus 1 over x plus 3, x minus 1, and x plus plus 5 maybe. Okay, so as you can see, I have a rational function here. It's rational because it's a fraction with both sort of x's on both numerator and denominator. Okay, now how do we know which one is the whole and which one is the vertical asymptote? But it's first it's important to know that they need to be factored out, meaning the numerator need to be factored out, the denominator also needs to be factored out. So I have given it to you in a factored form. Like this is parentheses times parentheses. So they are already factored out. Okay. Now, the first thing we need to do is determine what factor is in the numerator and also in the denominator. So this is that number right here, right? So the common factor, so the common factor, okay, that's your whole basically. So you need to set that one equal to 0. So in this case, those are the factor that is in the numerator and also in the denominator. So now what I'm gonna do is I'm gonna say x minus 1 equals 0. I'm gonna solve for that value of x, so therefore x equals 1. This is where the location of the whole for this function. Okay, so again, the whole is the value of x that will make the common factor equal to 0. Okay, and we will get another example later on. So that's the whole. Okay, now how do we know which one is the vertical asymptote? Well, the vertical asymptote are the factors in the denominator, okay, that are not part of the whole. So in this case, you have two of them. So now, so vertical asymptotes here, vertical asymptotes. Okay, so I'm gonna say, well, in this case, I have two of them. So I'm gonna say x plus 3 equals 0, and then x plus 5 equals 0. So now if I solve for each one, so you have x equals negative 3. That's one of the vertical asymptotes. And then I'm going to subtract 5 again here for because you have two of them. So x equals negative 5. So that means you have two vertical asymptotes. So if you were going to roughly draw this, let's say this is your xy axis. I'm just going to draw the vertical asymptotes at x equals negative 3. So let's say this is negative 3. 1, 2, 3, 4, 5, 6. So negative 3 is right there. So there will be a vertical asymptote here. And then there will be another vertical asymptote at x equals negative 5. And then you will have the graph. If we graph this function right here, then there will be some, this video will not really show you how to graph, just to locate your vertical asymptotes, okay? All right, so now let's look at some other examples. Okay, so again, the whole, you have to look for what is common in the numerator in and denominator, assuming they are factored out. Okay, so and then a vertical asymptote is the denominator factor value of x that is not common in your numerator. Okay, so let's look for one example. Okay, so let's say f of x equals 1 over x minus 3. Okay, all right. Are these factored out? Yes, the numerator is already as factored as it can be, and the denominator is also factored. So let's check for wholes. Okay, is there a numerator factor that is common in the denominator that has some sort of x? No. So this one here has no holes. Okay, no holes. Now, how about vertical asymptotes, which I'm gonna set as VA? It has to be the value of x, one of the factors, or factors in the denominator that is not in the numerator. Well, this is the only one left, right? So we need to find the value of x that will make that 0. So we can just pick that one, x minus 3 equals 0 plus 3 plus 3, therefore x equals 3. So this is where your vertical asymptote is located for this function, okay? Now let's try another example. Okay, so f of x equals x minus 3 and then x squared minus 9. Okay, well, first things first, we need to factor. Well, the numerator is already factored, but the denominator is not. So the numerator will just be x minus 3 because that's already simplified. The denominator, though, is a difference of two squares, so you can factor that one out. Square root of x squared is x, square root of 9 is 3, okay? So one is positive, one is negative. Now let's look. Is there anything in the denominator that's also in the numerator? Well, yes, there is. See this x minus 3, you get, if you put that in parentheses, that's equal to this point, this one right here, and that one, they are common. So if you want to find the wholes, okay, it's the common denominator, which is x minus 3, and you need to set that one equal to 0. Okay, so therefore plus 3, therefore your x equals 3. So you have a whole at x equals 3. That's not really the actual whole, that's just the location along the x, along that's the x coordinate of the point. If you want to find the actual point, then you kind of need to substitute that into your you need to substitute. This one right here can be simplified. When you cancel this one out, it'll become 1 over x plus 3, right? So this is the simplified form. If you substitute that 3, then you will get the value of y. So, well, let's say f of 3, meaning I'm going to substitute this 1 over x plus 3, then that would be 1 over 3 plus 3, then that becomes 1 over 6. So therefore your whole is located at 3 comma 1 6. Oh, that's not really 1 6. That's 1/3, but I need to put 6 here. So this is the actual point of the whole. There's only one. But if they would just want the value for x, then you can just stop there. Now, what about the vertical asymptote? Okay. Well, the vertical asymptote is it has something to do with the leftover denominator factor, which is this one right here. There's the only one left. So therefore, you can just equate that to 0. X plus 3 equals 0, minus 3 minus 3. X equals negative 3. So your vertical asymptote is x equals negative 3. You cannot just say 3 or negative 3 because it's not going to be aligned, right? So vertical asymptote is actually aligned. All right, so for that value, we have this is your whole, or that, depending on the question, and then this is the y, that's the vertical asymptote. Okay. Now let's look for a different one. Okay. So let's erase this and do a third example. Okay. So let's say those ones are pretty simple. Now let's look at something a little bit different. Okay. So f of x equals x squared minus 7x plus 10 over x squared minus 4x plus, I think this is minus 5. Okay. Okay, this is a plus 10 and then minus 5. Now again, first things first is you need to check the numerator and denominator needs to be factored out. So we need to factor the numerator and the denominator. Both of them are trinomial. So we can just I normally use this normally use this trick for when we try to do factoring. Okay, so I'm working on the numerator this time. If I have that numerator, I could do like this x thing, and then I'm gonna have the 10 here because that's your c, and then negative 7. So right now I'm factoring the numerator. So I'm gonna say what two numbers will you need to multiply that will make 10, but when you add will make you negative 7. Well, those numbers are negative 5 and negative 2, right? So negative 5 times negative 2 will give you a positive 10. Negative 5 plus negative 2 will give you a negative 7. So where did I get this 10 and 7? The 10 is your C and your negative 7 is the B. So therefore, the factor for the numerator are x and x minus 5 from here, and then x minus 2. So that is the numerator. Now we'll do the same thing for the denominator because it needs to be factored out. Well, what is the c in the denominator? You have negative 5. The b is negative 4. So now again, you think of two numbers that when you multiply will give you a negative 5, but when you add will give you a negative 4. Well, that's going to be a negative 5 and a positive 1. Double check. Negative 5 times 1, you have negative 5. Negative 5 plus 1, you have a negative 4. So therefore, those are your factors. So you have x minus 5 and then x plus 1. That's the first part. You have factored them out. Okay. So now we're ready to solve for the determine the what's the whole location. All right. So the whole again is the common factor. Here you have that x minus 5. So we're gonna set that one to 0. Okay, equals 0 plus 5 plus 5. So therefore your x location is at x equals 5. Okay. Now, if you want to find the simplified version of this after you cancel this 2, it's going to be x minus 2 over x plus 1. So if you find x of 5, f of 5, meaning you substitute this value of x into that, you will have x minus 2. I'm going to put this one first so you know where I'm substituting this. So 5 minus 2 over 5 plus 1, which is going to be 3 over 6, or equal to 1 half. So therefore, the whole is at 5 comma 1 half. That's the this is the coordinate, these are the coordinates of your of the whole of this function. Okay. All right, now what about the vertical asymptote? The vertical asymptote here is just whatever is left in the denominator, which is this. That's the only denominator factor, meaning what value of x will make that whole denominator equal to 0. So you can just say x plus 1 equals 0. I'm going to subtract 1 on both ends, so x equals negative 1. This is your vertical asymptote. You only have one, okay? All right, so if you have any more questions, please let me know and you can write it in the comments below. See you.